So question 21, physical quantities can be added together. Velocity and mass are examples of two types of physical quantities. Discuss how the addition of two velocities differ from the addition of two masses. So what this question is getting at is, do you know the difference between scalars and vectors? So I would start this off by saying velocity is a vector and mass is a scalar, and now we've just got to work out what the difference between them actually means. And so of course with a vector the direction is important, so vectors take account of the direction and scalars don't. Okay, and if we move on to part B, now we're looking at a stationary trolley on a smooth ramp. A short length of string is attached between the end of the trolley and the top of the ramp. Assume that the frictional force acting on the trolley is negligible when it is stationary or when it is moving. Now, other than the normal contact force, there are two other forces acting on the trolley, on the stationary trolley. So the first force would be, on figure 21, draw arrows to show these two forces. We do not need to name them, but the first force I would suggest is going to be on there is going to be the the trolley's weight. The other force, of course, is going to be pulling parallel to the string in that direction. Okay, and those are the two answers, and whilst it didn't say it, the third force is the normal contact force. So if we go on to part 2, here we're dealing with now when the string is cut at time is t equals 0. The trolley travels down the ramp with a constant acceleration of 3 meters per second squared, and we've got to calculate the time taken by the trolley to travel a distance of 0.8 meters down the ramp. So constant acceleration is screaming out for suvat. So let's write our letters down the side. What do we know? It's cut at time equals 0, but that's not the time we've got to work out. The trolley travels, but what we do know is because the trolley is being held up there, the initial velocity is going to be 0. Calculate the time. Oh, so we've got the acceleration, which tells us is 3 meters per second squared, and we're got to calculate the time, and the time is when it's travelled 0.8 meters down the ramp. So we don't know anything about the final velocity, so we need to choose an equation that doesn't have v in it. So that is going to be s equals ut plus a half at squared, and because u is 0, that term disappears, so we know that s is equal to at squared over 2. We're after the time. I always like to rearrange the equations first, so let's multiply up by 2, divide through by the a, and then take the square root, and that's going to equal my t. Now let's substitute some numbers in. 2 times 0.8 divided by 3, and take the square root, and that will equal a time of 0.73 seconds.